Hey, yay, we made it to the last page. Okay, we're going to go over number 10, which is finding horizontal and vertical asymptotes of the following function. So for the vertical asymptotes, to find those, you're going to set the denominator equal to 0 and find the zeros. Your copy says that you need to explain how you found them, which is why I have those written down. So for the vertical asymptotes, set x minus 2 equal to 0 and solve, you get x equals 2. Remember, vertical asymptotes and horizontal asymptotes are lines. So if you do not have x equals, that is not correct. First of all, I won't know it's a line if you just have 2. Second of all, I won't know if you understand that vertical asymptotes have to have x equals, horizontal asymptotes have to have y equals. Okay, so vertical asymptotes for both A and B, you're going to set the denominator equal to 0 to find the zeros. For B, you're going to have to factor the denominator and then solve, and you'll get x equals 1/2 and x equals 4. Now for the horizontal, you are going to use your rules. So for part A, since the degrees of the top and the bottom are equal, the horizontal asymptote is the fraction formed by the leading coefficients. So my leading coefficient for the numerator is 2, so this would be 2 over 1, which is the leading coefficient of the denominator, and then 2 divided by 1 will be 2, so y equals 2 is my horizontal asymptote. For B, I'm going to compare the degrees of the top and the bottom. So for this one, the degree is going to be of the numerator is less than that of the denominator, which means that you're going to have y equals 0. Okay, whenever the top degree is less than that of the bottom, the horizontal asymptote is going to be y equals 0. Okay, and if you don't remember those rules, I would definitely write them on that little note card that I'm letting you use on your test. Okay. All right, 11, we are going to graph. We have to find the x-intercept, y-intercept, vertical asymptotes, and everybody's favorite, domain and range. So for the x-intercept, to find those, you have to do the zeros of the numerator. So for the 0 of the numerator, I just have 81. If I set that equal to 0, I have nothing to solve for. So 81 is not going to be 0. That means there's going to be no x-intercept. Okay, for the y-intercept, I'm going to plug in 0 for x. When I plug in 0 for x, the top stays 81, the bottom's going to say negative 16. Leave this as an exact answer. Okay, so leave this as just negative 81 over 16, your y-intercept, and then I'm just going to write that as a point. So 0, negative 81 over 16. If you want to write that as a mixed number, you can. 16 times 5 will be 80, so it'll be negative 5 and 1/16. If you want to write it as negative 5 and 1/16, that is perfectly fine as well. Okay, then we're going to find the vertical asymptotes, which remember are going to be zeros of the denominator. Now when I factor this, I'm going to get x squared plus 4, x squared minus 4. Okay, now you cannot factor x squared plus 4. If you wanted to factor x squared minus 4, you could go ahead and do that. You could also just set these equal to 0 and solve. Once you try to set this equal to 0 and solve, this is a negative. Okay, so you would get imaginary values. You're not going to have imaginary values with asymptotes. Your imaginary values are not going to be on your graph. So the only values you will have are going to be plus or minus 2. So x equals 2 and x equals negative 2. Like I said, you could also factor this. So if you factor this into x plus 2, x minus 2 equals 0, you could find your asymptotes that way as well. The horizontal asymptote, the top degree is less than the bottom, so y is going to equal 0. So when I do my graph, I'm going to make sure that I label my asymptotes, especially this one, because I'm not going to be able to see that. I put my arrow here so you could see that I do have my asymptote there. You can also, if you have a highlighter, or that's perfectly fine, but I'm going to be looking for if you have this labeled. And then your asymptotes here, they're dashed lines. They need to be dashed lines. If they're not dashed lines, then that indicates it's part of the graph. And these are just going to be the asymptotes of your graph. Okay, and then you can use your table on your graph to make sure that you have accurate points here. So when you graph this, make sure it's 81 over, and then in parentheses, x to the 4th minus 16. And then you can use your table to find some accurate points there, which I'll go over that with you. Sorry for the turbulence there. Okay, your domain, which is going to be written in set builder notation. For the domain, it's always going to be all values of x such that x cannot be the vertical asymptotes. Because remember, whenever you have a fraction, the denominator can't be what? 0. Good job. I know you said it at home, didn't you? So once you realize that it can't be 0, you would set the denominator equal to 0 and solve. But that's exactly what we did for our vertical asymptotes. We set the denominator equal to 0 and we solved. Okay, so you don't have to do that again. We just know that it can't be equal to the value of those asymptotes. Now, for your range, you're going to have to look and see where your y values are. So can you see here that all of your y values are going to be lower than this maximum, or they're going to be higher than this line here, your asymptote at y equals 0. Sometimes it will cross this line. If it does, you can just find out what that value is. Oh, sorry. You can find out what that value is, and it would just be greater than that. But in many, many cases, you are going to have your upper branches be greater than what your asymptote is. So I graph this on my graphing calculator, and then if I want to go to my table, I can find some points here. Oh, yeah, let's not start at 1250. Let's start at 0. Let's go by ones. Okay, so here's going to give me some good values. So like at 1, I'm at negative 5.4. So that would be a good point to plot. At 2, there's going to be an error. At 3, I'm at 1.2. At 4, I'm at 0.33375. You can use your table to see what happens in between like 2 and 3. Remember we did that in class where you can start your table at 2 and then you can go by like tenths. So you can see, okay, what's happening here? Like at 2.1, it's all the way up at 23. So that's pretty steep. At 2.2, it's up close to 11. At 2.3, it's up close to 7. So you can go ahead and estimate that part on your graph. Okay, now I'm going to just set my table back to go by ones. And then when you have your graph, okay, because this is a parabola, I'm going to find my maximum because that's going to be part of my range. So I'm going to go to second calc, go to my maximum, okay, and I'm going to go to the left, go to the right, and then try to get right on my maximum there. Okay, so my maximum value, remember this means x is 0, but you aren't even going to worry about that because range is going to be with your y's. So it's at negative 5.06. And I'm going to round that to the nearest tenth. Whatever your directions say to round it to, you can do that. If they don't say the nearest tenth or the nearest hundredth, both of those are acceptable. So all of my values for y are going to be less than or equal to negative 5.1, or they're going to be greater than 0. So to double check that, I can just go ahead and look at my table, and I can see from my table that my values are going to be getting closer and closer to 0. Okay, but they're not going to be reaching 0. Oh, message from my man there, and I said be quiet when you come in because I'm recording. And good times. Okay, so all right, that is number 11. Let's actually do number 12 real quick. So explain without graphing. the following function has a slant asymptote, be specific, then identify the slant asymptote. So you have to know that the function has a slant asymptote because the degree of the denominator is 1 less than the numerator. Okay, it's going to be, you can say the degree of the denominator is 1 less than the degree of the numerator, or you could say the numerator is 1 more than that of the denominator. So either way, that would be fine. So to find that, we are going to use long division. I put my placeholders in, and then we have fractions, so that's always fun. So x cubed divided by 2x cubed is, divided by 2x squared is going to be 1/2 x. Then I'm going to distribute. I'm going to make sure I line these up with all of the like terms. I'm going to switch my signs. When I do that, I get negative 1/2 x squared plus 1/2 x plus 4. Again, I'm going to divide. Negative 1/2 divided by 2 is just like I'm doing negative 1/2 multiplied by 1/2, which is going to be negative 1/4. So when I distribute, I have 1/2 x squared. That would be negative 1/4 x, and then positive 1/4. I'm going to switch my signs, and then really you wouldn't even have to continue with this step because you know that your answer here is just going to be an x, which is 1 less than this degree. Because this degree is less, we're done. And the slant asymptote is only going to be your quotient. Okay, so you don't have to write that domain. You don't have to write the remainder at all. Okay, so it's only the quotient. So y equals 1/2 x minus 1/4. And then you have to have y equals because it is a what? Let me hear you say it. It's a line. It's a line. So it has to have an equation. There are 13 questions on your test. It'll ask you for an explanation, just like some of the ones on your review have done. Good luck studying. Get a good night's sleep, and see you folks tomorrow. Bye.